everyone. Welcome to Risk Roundup. The potential of autonomous system is exciting many across nations. The reason is autonomy is driving innovations and revolutionizing industries. The emerging innovative potential is enabling entirely new intelligence and automation capabilities and surveillance capabilities for human environment and ecosystem where direct human control is not physically possible. Moreover, since the underlying technology of any potential autonomous system is capable of adapting to changing conditions, knowledge, and constraints, it is also possible to assign very broad objectives. As a result, new ideas and initiatives are emerging rapidly to explore the capability of such autonomous systems. To discuss one such idea and initiative, I'm delighted to welcome Fabio Alonso da Silva to Risk Roundup. Fabio is the Chief Technology Officer and Head of Systems at Elletrocrafts Aerospace, and he's based in the United States. Welcome, Fabio. We're honored to have you on Risk Roundup.
I'm honored to be part of this too. Thank you so much for the invite.
Wonderful, Fabio. So, from your assessment, how important is autonomous systems technology becoming for initiatives and industries like yours without you having to share anything confidential or proprietary that you are working on?
Okay, one of the greatest impacts is on safety, especially when we apply an autonomous systems for self-driving cars. Right. According to NHTSA numbers, we have around, or we had in recent years, almost 40,000 deaths caused by car accidents. Okay, so the biggest impact, the first biggest impact would be in safety and in the decrease of those numbers. Okay, the second major one would be the economic impact, especially for companies deploying mobility services like Uber, for instance, right? So if we look at information we can, gather from the internet of Uber costs per ride, the information that we have is that 70% or 70% or 70 cents of a dollar is to cover, drivers' costs, right? When you take the driver out of the loop, right, then those 70 cents, they become profit in a way, you see. So there are those two major subjects which impact the society as a whole: safety and company earnings, right?
Yes. Yes,
okay.
No, definitely. Safety and, economic efficiency, those things are important. And while they do create other, additional security risk, we will have to, evaluate for the broader society, and we'll have to come up with effective response to that so that, society doesn't get impacted in a really negative way. But you are right that these systems, autonomous systems, are very beneficial because for our global viewers and listeners, I want them to understand that autonomous systems, autonomy is very different than automation. So what trends you are seeing in your industry and other industries broadly for developing autonomous system, not automation, because there is a broad initiatives going on pretty much across every business, every industry, every enterprise, to create automation solutions so that they can get the speed and cost efficiency and what they're looking for in any of their initiatives or whatever outcome and output they're looking for. But those automation solutions are very different than autonomous solutions that we are trying to develop. So can you explain our global viewers and listeners what trends you are witnessing across industries for developing autonomous systems?
Okay, I believe that there's a hype around the autonomous systems application to every sector in the economy and in the world, and that's it. It is understandable, right? Because it's new, it's super interesting, it's cool, right? But now we have to understand the differences between what is an automatic system and what is an autonomous system. Right, and what is the functionalities that each one covers, right? So to make it pretty simple, I have my own definition of what an automatic system is. what it does is pretty simple. It follows a reference, right? And make sure that whatever it is controlling follows the reference, right? Now, the autonomous system, I would say that sit on top of several other automatic systems, right? And what it does, it receives information from all other, automatic systems, make a judgment, right? And makes the decision of readjusting set points for each one individual automatic system. And this is pretty simply put, right? So, and I'm talking about, and I'm describing like that based on the application we are looking for self-driving cars and self-flying vehicles, right? So, and then there's that difference between what we want the autonomous system to do and what is it that automatic systems need to do. To give you a more concrete example, for instance, in an aircraft, we have the autopilot, right? We have the auto landing system. We have the auto throttle system. And what they do, once the pilot defines the set points, each one of those individual systems, they follow whatever reference was defined. See, now the autonomous system is replacing the pilot in the situation awareness, in the performance of the functions it needs to do, right? And in taking action. So whenever we understand the difference between the functionalities that each one has to perform, then we can have a better understanding of what autonomous system is. So, yes. and I believe that that concept has to be understood by each one of the companies applying AI. And AI, it's a broad field, right? But but they need to understand a clear understanding of what are the functionalities they need to be purely automatic and purely developed in an autonomous system. And this derived from the understanding of what the functionalities are, what you need to do. At the end of the day, we are talking about each specific type of requirements each one of those companies have for their own case.
Yes, very true, very true. So you made an interesting point that we are seeing a difference here. A lot of, automatic systems, not autonomous, automatic systems, they create a system that can interact with those, layers of automatic systems, and it controls it. So you think it is possible at this point, with the current advances that we have in the AI broadly and in the autonomous systems, that we can create a system that can monitor or control each of these automatic systems that we have developed within, let's say, business environment? Is it possible that we have reached a point that we will be, with the autonomous system that we develop, we can create commands, or we can give control to that autonomous system, that it can create all the automatic systems, like you just said the layers of it. But I'm thinking broadly that within a company, or let's say self-driving cars, even just for that it will be able to create all the automatic system if we create an autonomous system.
Look, let me give you an example. Aerospace has several automatic systems working together already, and I'll list them: the autopilot, the auto throttle, auto landing. Those are already automatic systems, right? In the automotive world, there are also similarities. There are, the ADS systems, right, which are the assistant driver systems. And what they do, they are automatic in their own right too, okay? So, and yes, at the level of technology we have today, and looking at what the companies, especially in the self-driving car world, are doing, okay? we have examples of autonomous systems already in operation, like Waymo is operating already in Phoenix, right? They deploying the service in Phoenix. So yes, the autonomous systems do control the automatic system. So I would say the autonomous systems, if we define a hierarchy, they sit on top of all other automatic systems, right? But the thing is, the complexity in resolving the dynamics of traffic is so huge that for the self-driving world, right, what's going to happen is that they're going to increase their operational design domain little by little. What it means is that to make sure that they have, to build confidence and to make sure that they develop and deploy a self-product to the market, right? The strategy is to expand gradually the operational design domain, or ODD, in which they're going to be little by little incrementing the level of functionalities, expanding the level of functionalities until they can reach the full autonomous level, or so they can operate 100% in autonomous mode.
Yes, no, that's good. So, but the example that you gave about that, we already have several, automatic systems that, are being controlled by autonomous systems. So let's take a hypothetical scenario that one brand like Uber, or, has, a lot of automatic systems in their autonomous cars. And they have a controlling autonomous system that controls all those automatic systems. Now, Google, I'm just giving a hypothetical scenario that Google also has autonomous cars and autonomous system, and they also have a lot of automatic, systems which is controlled by the autonomous system that they have developed. But it's possible that they have an extra automatic system that Uber doesn't have. Now, both the cars are on the road. So will the autonomous system of Google, who has an extra, automatic system that is controlled by their autonomous system, will that somehow create, some kind of conflict interaction with the other car, because they also have a controlling system, autonomous system, but they don't have that particular, feature that is automatic. So do you see this kind of cross interactions happening between automatic systems and autonomous systems for two different brands that are, having their autonomous systems on the road at the same time?
Okay, look, let me start answering that question by going up a level, right? One of the first challenges, and I believe it's one of the most important challenges right now, is that so far we don't have a framework that defines how to go about designing autonomous systems into a self-driving car. And NHTSA has released a document asking people to suggest what would be the best roadmap to achieve that. I mean, to come up with a set of rules, or either processes to properly design an autonomous system. And the name of the document is the Advanced Notice of Proposed Rulemaking, right? So then that is the first challenge, right? Is to define, okay, how can we design an autonomous system if we don't have textual regulations saying how to go about it, right? That's the first step. And in the aerospace world, the FAA has the federal regulations, right, to address design of aircraft and their systems. So there's one specific item there that talks about how to design the autopilot, okay, and how to design systems and automatic systems, right? We don't have something similar for autonomous systems yet, but what we have been discussing is, okay, we have to start by understanding what the autonomous systems need autonomous system needs to do, right? So if it is replacing a human being, so it has to be aware as a driver would be. It has to react as a human driver would react faster, right? And it has to be safe, right? So, and those three little statements, right, they break down into lots and lots of engineering activities, right? So, and those things, they will start giving people like a path to go through, and some of the companies they are pretty close of doing that. But looking at those statements, you could eventually understand if there is any gap in the current processes each one of those companies are applying to develop their autonomous car.
Sure. Now, I hear you on that, and yes, we do have to come up with a framework and guidelines for all these different processes. But if you look at all these spaces like geospace, I mean, where we are having many initiatives for autonomous cars that will go on the roads. If we look at aquaspace in the ocean, waters, we will have many initiatives going there. We will have many initiatives in the outer space and deep space, for many of the initiatives. And same thing for cyberspace. There are the AI warfare has already begun, and we are looking at many systems emerging for network security to cyber security, where they are all going to be autonomous. So, and we don't have only one vendor or one supplier or one tech company building those systems. We have many companies building those systems, many initiatives. So when you talk about autonomy, where humans will have no role at certain point, and where the system will just take decisions on its own. That is the basic difference between automatic and autonomous, that we will have no control. So when we create these autonomous algorithms, and when we let it loose in the spaces, irrespective of whether it's cyberspace, aquaspace, geospace, or space, then how would we know what they do? How would we know that how they are not only controlling their automatic systems for which they were designed for, but that they are interacting with other autonomous systems. Then they will probably try to control other automatic systems. So how would we know where those autonomous systems will take the next step? Because at certain point, humans will have no control. So how do we define algorithms, or how do we define systems where we will have some sort of control, even though we have created autonomous system, so we know what is going to happen and where it is going to go next?
Okay, so in your question, I see two important things. One is either the autonomous system taking a wrong decision and causing catastrophic consequences to society, to drivers, to passengers, to pedestrians, or even passengers in an aircraft, right? And the other thing, which is also important, is how much of automation, or how much of autonomous systems we would like to have in certain aspects of our everyday lives, in such a way that they eventually take control of everything. So those two different aspects. The first one, which relates to autonomous systems in control of a autonomous car, or in control of a self-flying vehicle. What I can say is that per the process, right, and especially in aerospace, we have a pretty demanding and rigid process to follow, right? If we follow the process of design that is defined there, right, we address the cases where we either lose a system and it creates lots of problems, or a system behaves in an unwanted way and creates problems too. Now, if we follow a process like that, which is pretty standard in the aerospace world, right, we eliminate the probability of such thing happening. Okay, So then it kind of answers the ethical question that we've seen being discussed in the media, right? What if autonomous car takes the decision of turning the wrong way, or what if it gets into a situation in which it has to decide between saving the passengers or saving a pedestrian? Well, if we follow a process like we have in aerospace, we would never need to answer that question unless the process was not properly followed, right? If a wrong requirement was not detected and it flows down to the final product, we might have a problem, but the process is there to avoid that. The process is there to make sure we have a safe product with high levels of quality. Now, in terms of AI being applied to every other segment of our lives, in a way, it helps, right? Especially when we're talking about AI applied in diagnosing, in diagnostics of patients, which it's more precise and faster than a doctor, for instance, right? So that's advantage of its usage. Now, I cannot comment right now about what would be the bad, influences or consequences of AI being applied to everything in such a way that we would lose control of our lives. But it's something that for sure it needs to be looked at, and proper measures have to be put in place to avoid that. Right? We don't want to.
Measures. What kind of measures could control?
Okay, look at measures in the sense of limiting what type of decisions these systems are capable to make. Okay, so you need to put some limits, right? And it has to be broadly discussed and decided by each one of the industries applying AI into the development of their processes, into the development of their products or services being offered.
But let's say, for initial initiative, we define and design in such a way that we can control it, but it is an autonomous system. So it can then decide that, okay, why do I not need to do this? I want to do this. It can have its own mind. Then it can, start doing things that we don't want, we did not design them for. Then what?
Well, then it is the case of in your development process, right? Establishing requirements for what it has to do, right? And requirements to protect against things you don't want it to do, right? So, and then when you have defined those requirements,
if you put that in the code, will that stop the algorithm to not do what we don't want them to do?
It depending on the application. So when we are talking about safety measures, it is not just about the code, right? It's about the hardware and how we play with the architecture of hardware or putting the pieces together, right? To also avoid something wrong from happening, right? Now, and this example meets the challenges we have in the self-driving car and self-flying vehicles landscape, right, or ecosystem.
When you say it depends on the hardware, what role hardware plays here? What kind of hardware could create those kind of scenarios which we are talking about, where the autonomous system could go out of control?
Yeah. In our airplane or even in a car, when you're applying autonomous systems, right? You have the control boxes running software, right? Okay, so failures can be caused by a software. I wouldn't say software failure because it's not necessarily a failure, but it's more like a requirement being bad implemented. So software, it's a reflection of requirements defined at a prior stage. So if something goes wrong in software, pretty much you have a wrong requirement in place. Now we have hardware that also is the infrastructure on which the software runs. and performs the functionalities, right? So you might have a little component failing, right? And eventually sending a signal which was not supposed to be sent at that moment and generating, a wrong command. Like instead of braking, it accelerates. It doesn't brake when it needs to brake. Or instead of following a trajectory, linear trajectory, it decides to turn when it is not supposed to turn. So when we break down the safety requirements into software and hardware requirements, we make sure that the hardware architecture has enough integrity and redundancy to avoid catastrophic scenarios. Okay? This is how we in the aerospace and also in the self-driving car ecosystem solve that problem. You see?
So it's hardware will be able to give us that answer that we are looking for, whether some autonomous systems will be able to not, whether they will be able to be controlled by us or whether we will lose control. So it's the hardware that is the key here, not this algorithm, not the software.
Well, in fact, are those two things working together, right?
Yes. Yes.
Okay, so now the fact that the autonomous system can release control back to a driver, for instance, it's a matter of how it's implemented, right? So, for example, we have the autopilot feature in the Tesla cars. So you can turn on and turn off at your own will, right? And if there's anything wrong, the system is going to alert the driver to take control, right? As far as I understand how it works, right? Now, in other solutions, that might not be the case. So I believe that protections we're going to be put in place for other autonomous cars, either operating in a fleet, a taxi fleet, or being sold directly to consumers. So they might decide to have a different solution. What they can do is just, look, there's something wrong. We detected something wrong. We are not continuing with our ride. We're gonna, park and wait for help. See, it depends on how each company is gonna define its operational profile based on, its operational needs and safety requirements.
Sure. Now, let me ask you one question. There are several autonomous systems already, let's say implemented. If we talk just about the cars, autonomous cars, and there are, like initially we talked about, that Google's and Uber's or any other companies, or Tesla or any other company's autonomous cars are on the road. There are a lot of autonomous algorithms implemented to control those cars for each specific, supplier, each specific, company. Now, under what conditions one autonomous algorithm will start talking to other autonomous algorithm? Is it possible that those all, let's say, Tesla, Google, or Uber, all three autonomous algorithms, that do you see a possibility that they can start talking to each other even though we have not defined them to talk to each other?
Look, we have to make a difference here between what the autonomous systems do, right, and how they interact, right? So, look, the most important thing is that either Uber, Waymo, Lyft, Aurora, Signia, and all other Stark or all other companies developing autonomous systems for cars and trucks need to do is to have in place and demand that from NHTSA to have proper guidelines, proper regulations, right? So once there's a framework defined, then and each one follows that framework, they can choose whatever they want as suppliers. They can have different blends of software, different AI equations. It's not about that, but it's to make sure that each one of the solutions at the end of the day meet the safety criteria. That
sure.
is,
but my point.
Okay, let me finish. I'll answer your question now. The thing about having those different products communicating with each other is something else, right? It's not necessarily the autonomous code, autonomous software used to control each one of the cars. But what we can do and what we are foreseeing for the future is that not only these autonomous cars can be talking to the city infrastructure, right? But also can talk to other cars in terms of grabbing information and understanding what each one is doing, so in such a way that they can avoid like a collision, right? So but then it doesn't have to be necessarily implemented by AI, right? It can be just a simple communication protocol, right? Which would, you know, define how everybody has to communicate to inform each other what they're doing. Now there's the another important thing, which is the fact of intelligent cities, right? With, you know, grabbing information about all aspects of the everyday life, and even traffic or weather, see, or traffic jams. So whenever the city infrastructure or the smart city infrastructure is able to relay that information to the autonomous cars, we can improve the riding experience in terms of avoiding traffic or avoiding accidents. You see?
Sure. That's a good point. But the point that you made about communication protocol, I think it's very interesting, because I'm thinking all the autonomous systems that are being defined, everybody has their different, you know, design criteria, different, you know, features that they have implemented in those algorithms, in the autonomous algorithms. Is it possible that someone creates that communication protocol or communication algorithm that can, you know, even that can start communicating to all the autonomous systems, autonomous algorithms that are out there, and make them do what they were not designed to do? Is it possible that, you know, such algorithm could be created, and communication algorithm that can create, you know, a scenario which will be impossible for us to control at certain point, because it will start giving commands to all these different, you know, autonomous systems for which they were not designed to do, because it is a communication protocol, it is a communication algorithm, and it is able to communicate to each of these autonomous systems.
Okay, so look, some of the operational models, right, expect remote control from like a control tower. If we think about how something similar in the aerospace world, right? So when there is a problem in an autonomous car, it would send a message to its control tower, and someone in the control tower will take control over that specific vehicle and you know, perform safety measures like, you know, parking and informing the passenger that the car cannot longer proceed with the travel and so forth. So, and in that case, that piece of communication has to be protected, and there are efforts in the field of cybersecurity to make sure that the communication between the car and the control office or the control tower is not hacked or corrupt. So the same thing needs to happen when all these cars are communicating amongst themselves. You need to provide a level of integrity and make sure that no wrong command is being passed down to the fleet. Okay. Now, when we talk about communication with other cars, right? We need to have in mind that it doesn't mean that one car is capable to control the other one, because it needs to. We need.
It could happen.
No, because per design and per definition of requirements, we need to put in place what we can call a firewall, right? To avoid that any communication can interfere in the commands that AI is generating to the automatic systems down in the chain, like and steering system, brake system, throttle systems, right? So this is why a requirement-based design is so important. So the integrity of the information has to be kept at all costs. And this type of communication with other cars and with the control tower cannot interfere or cannot make an autonomous car to behave in an unsafe way. And this is why requirements are important. And we need to design our systems to meet that goal. You see,
yes, so absolutely. I hope that we are able to contain the communication and we are able to control the communication to all these autonomous systems through the control box that you were just talking about. Yeah. But I'm looking at the scenarios where it's not just the hacker, but let's say nation states. They decide that they want to, attack United States and they want to somehow create a communication protocol that would, start giving commands to all of our autonomous systems for which they were not designed for. So these are just futuristic scenarios I'm thinking about. That what if, using a communication protocol, what if, somebody creates a new kind of hardware and, comes up with enough, infrastructure power that they need to be able to control and communicate with all the autonomous systems, then we would be, talking about security challenges that we have not thought about, because then we have to figure out how to, will we have a kill switch to stop all the autonomous systems? So that brings another question, that in case these kind of scenarios emerge, will we be able to stop all the autonomous systems? Will we be able to, control them?
I believe that by the availability of technology that we have today, that's pretty unlikely to happen. There are protections in place which would avoid that type of scenario from happening. I mean, we can play with the concept of redundancy, right? So when let's say autonomous vehicle receives information from any other, it has to confirm that information. So, and it has to have ways of confirming that information before accepting it.
Confirm? How do they normally confirm the information?
Well, there are some technical solutions to do that. Either you can add, sensors to this specific unit, right, to make sure it is able to cross-confirm whatever information it's getting from the external world. Or what it can do is ask a third party, right? It doesn't have to be another car, but it can be the smart city infrastructure, right? Now, can all those things be affected and hacked at the same time? Yes, but it's gonna be pretty hard to happen.
Yes, I hear you, but you are right that, if it is possible to create those kind of control towers or external system to which, they have to communicate and ask whether they were, asked to do this, whether the commands that they are receiving, the communication they are receiving, whether that's a legitimate communication. So if we can create such structures, we can protect ourselves. You are right. And yes, there will always be that, minor chance that, all those systems, control tower and communication protocols and everything could be hacked at the same time. But if we create checks and balances, if we create, proper processes and tools and technology, then we will be able to protect ourselves. So you are right about that. It would be difficult, and not many countries will have that kind of power. But it is good to think about all possible scenarios where things could go wrong, because we are creating autonomous systems and we are creating systems where humans do not need to play a role to, do a lot of, work. And we are not talking about just, autonomous cars. We are talking about autonomous systems that will be in the space, that will be in aquaspace, that will be in cyberspace, which connects everything. Cyberspace connects aquaspace, geospace, space. So we are talking about many security risks that could emerge. So let me ask you this question. As you design all these systems, as you try to create solutions for the industries that you work with, what concerns you most? And where do you think we need to focus on more research? Because we just don't have enough information and enough answers yet for us to be able to create or design systems for which, we are trying to try to solve problems, the kind of systems that we need to design, the kind of features that we want to incorporate, where do you see we need to focus more on, more into research and development?
Okay. The first thing, and again, I'm going to repeat myself, but it's pretty important, is the whole industry needs to collaborate with NHTSA to come up with a framework. And this framework, I suggested in the report that I wrote for the SAE. Now, the most challenging point right now is in the verification of AI generated software, right? It's so far it is not certifiable by the standard rules that we have. So we have to come up with different approaches to make sure that the AI software is safe. And one of the things that we do as safety engineers is play with the concept of dissimilarity, right? So since now the AI equations, AI functionalities have a probability of outputting the wrong result, so a way, to cover for that problem is to have different equations trying to solve the same problem and comparing them together. This is something that the aerospace world is doing forever in its fly-by-wire systems and all other critical, safety critical systems, and it works so far. And aerospace is the most safe industry ever, right? So the same type of apply to this can cover us against those type of problems. This is how I see.
Yes, no, very true, very true. So what would you like to tell our global viewers and listeners? I know you cannot talk about your initiative because it's very confidential. Everybody who is working on such systems, they cannot share, what they're working on until they're ready. And so without, sharing anything proprietary, what would you like to tell our global viewers and listeners, especially those young minds who are so, passionate and who are so full of knowledge and ideas that they want to, contribute to, creating positive benefit for the society. But there are also a lot of, young, brilliant minds who are going on the dark side and trying to create problems. What would you like to tell them?
Okay. What I would really like to tell them is that self-driving cars are happening. Self-flying vehicles, they are happening, right? And it might take us a little bit of time to mature technology, to mature the processes, to define the frameworks, but they are happening, right? So, and it's a pretty interesting and new road, and we believe we are going to write a new chapter in history, right? And this is one of the things that motivated me to join this autonomous system space, right, to contribute to that. So, it's going to need a little bit of work, but it's going to be there. Now, I can talk a little bit about my enterprise. There's no problem with that. So we are Elletrocrafts Aerospace. We are, designing a flying vehicle, right, that in the near future is going to have an autonomous system as well. And we believe that with that, we can contribute, to the role of the society in terms of, solving one of our greatest challenges that we face every day, which is transportation, which is traffic jams, which is, time is precious, time is money. So if we can, meet the demands that we see currently in our world, I guess we're going to succeed. Not just as a company, but also proving that this technology works, it is safe, and it helps society in general.
Yes, very true. And I hope you are working on an autonomous flying car. That would be amazing to have, So
Yes.
I hope that the initiatives that you are working on, that they succeed. And we all, including our global viewers and listeners, we at Risk Group, we all are, rooting for your success, and we all wish you the very best. So thank you so much, Fabio, for participating in Risk Counter today. appreciate your thoughtful insight on designing an autonomous system, and our global viewers and listeners would benefit tremendously from the information you provided, and from the passion that you show about creating such a safe and secure solution. So this Risk Roundup dialogue has been of service, and we thank you for that.
I'm very welcome to participate in this effort. Thank you so much for having me.
Wonderful, Fabio. So thank you so much. So Risk Group is a strategic security risk research platform and community, and our strategic security community and ecosystem is the first and only cross-disciplinary and collective community that is made of the scientists, security professionals, thought leaders, and entrepreneurs and philanthropists and policymakers and academic institutions from across nations collaborating to research, review, rate, and report strategic security risk to protect the future of humanity. Add your voice to Risk Groups to be a contributor or member. Please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.